Robert Oppenheimer was born April 22, 1904 in New York City. He graduated as valedictorian of his high school class in 1921, but fell ill with a near-fatal case of dysentery and was forced to postpone enrolling at Harvard. Once he enrolled in Harvard in 1922, he graduated 3 years later and realized that his true passion was the study of physics. In 1925, Oppenheimer began his graduate work in physics at Cavendish Laboratory in Cambridge, England. J. Thomson, who has been awarded the 1906 Nobel Prize in Physics for detecting the electron, agreed to take on Oppenheimer as a student. He later became good friends with Ernst Lawrence, one of the world's top experimental physicists. In 1926, Oppenheimer went to the University of Göttingen to study under Max Born, obtaining his Ph.D. at just the age of 22. During this time, he published many important contributions to the quantum theory, one being the Born-Oppenheimer approximation. The quantum theory is one of the two main planks of modern physics. Technically, the quantum theory is actually the theory of any object isolated from their surroundings. It essentially becomes a theory of the microscopic world of the atoms and subatomic particles. After the 1939 invasion of Poland by Nazi Germany, Oppenheimer was elected to administer a laboratory to carry out the Manhattan Project, the program that developed the first nuclear weapon during World War II. Oppenheimer was known as the director of the Los Alamos Laboratory and responsible for the research and design of the atomic bomb. He is often known as the father of the atomic bomb. Before the Manhattan Project was launched, Oppenheimer had already been doing experiments on fast neutrons, calculating how much material might be needed for a bomb and how efficient it might be. Prior to his assassination in 1963, President John F. Kennedy announced Oppenheimer would receive the Enrico Fermi Award for his achievements in physics. Physicist Enrico Fermi built the prototype of a nuclear reactor and worked on the Manhattan Project to develop the first atomic bomb. The Fermi Award is given to scientists who have helped mankind advance in energy science and technology. Oppenheimer died in 1967 from throat cancer in Princeton, New Jersey.
Hi, my name is Tammy. I'm part of NA News. It's very nice to meet you.
Hi, my name is Caesar, and this is my partner, Evan. We are scientists here at CERN. It is very nice to meet you too.
I just wanted to ask you a few questions about CERN. To start off, what does CERN stand for and when was it made?
CERN is a French acronym and it directly translates to the European Council for Nuclear Research.
It was formed in 1954 and is composed of 22 member states. Of those states, some are the United Kingdom, Switzerland, and Germany.
Where is CERN located and what do you do at CERN?
CERN is located on the Franco-Swiss border near Geneva. Our purpose is to answer the questions of the universe, with our main ones being what started the universe and what is it made of. We do this through the use of our particle accelerators, more specifically with our Large Hadron Collider.
And what exactly is the Large Hadron Collider?
World's largest and most powerful particle accelerator. A particle accelerator speeds up and increases the energy of a beam of particles by generating fields that accelerate the particles, and magnetic fields that steer and grip them.
These accelerators were created for the purpose of exploring the atomic nucleus. Through the use of the collider, we have found the composition of the atomic nucleus and the atom itself, and we have even found the existence of new particles.
What are these new particles?
These new particles are known as the Higgs boson particle, the pentaquark, and the first antiatoms.
Dubbed the God particle, the Higgs boson makes up all elementary particles and is a manifestation of the Brout-Englert-Higgs mechanism. This mechanism is a proposal that helps complete the unified theory equations. The unified theory is a theory which implies that electricity, magnetism, light, and some types of radioactivity are all manifestations of a single underlying force known as the electroweak force. As said by LHCb spokesperson Guy Wilson, the pentaquark is not just any new particle. It represents a way to aggregate quarks, namely the fundamental constituents of ordinary protons and neutrons, in a pattern that has never been observed before in over 50 years of experimental searches. Studying its properties may allow us to better understand how ordinary matter, the protons and neutrons from which we're all made, is constituted.
Now, back to the antimatter and antiatoms. 20 years ago, a team of scientists at CERN, led by Walter Ohlig, succeeded in producing the first atoms made of antimatter particles. The 9 atoms of antihydrogen, the antimatter counterpart of the simplest atom, hydrogen, were made at our Low-Energy Antiproton Ring Facility, or LEAR for short. This happened exactly 30 years after the discovery of the antiproton and opened a new chapter in the study of antimatter. Comparisons of hydrogen and antihydrogen atoms constitute one of the best ways to make precise tests of the differences between matter and antimatter. Their makeups are predicted to be about the same, so tiny differences would open new pathways to new physics and could help in solving the antimatter mystery. The atoms produced in 1995 remained in existence for about 40 billionths of a second, traveling for 10 meters at nearly the speed of light before being annihilated by ordinary matter and producing the signal that showed that the anti-atoms had been formed.
7 years later, our Athena and HAP experiments successfully produced large numbers of antihydrogen atoms for the first time. We did this using our antiproton decelerator. Early 2015, further advances were made when the baryon antibaryon symmetry experiment report the most precise comparison of the charge to mass ratio of the proton to that of its antimatter equivalent, the antiproton. The study, which took 13,000 measurements over a 35-day period, showed that protons and antiprotons have identical mass to charge ratios. The AEGIS experiment, which just started up this year, is designed specifically to measure the gravitational interaction of antimatter. Another future experiment, GBAR, will make similar investigations.
Well, that's all the time we have today. Thank you for having me. It was a pleasure having you.